Hey everyone, it's Zach from Peeling Back Data, and today I'll be running you through how to do column and bar graphs in R using ggplot2. This video will be long, so I'll make sure to add timestamps in the description for where each section is. Feel free to skip ahead if something isn't relevant to you. So what we'll be doing to start off with, like we did in the previous video, we'll be loading in the library ggplot2. So today we'll be looking at the diamonds dataset. So to see what that's about, we can go $diamonds. So diamonds looks at over 50,000 observations of diamonds and looks at various variables such as the price, carat, and the cut. Now what I'm going to go and do is assign data to be diamonds, and then we can go have a closer look at it in the environment. And click the drop down arrow, and we can see that there's ordered factors in this data set, which is good because that's what we need to do for bar plots. So you can see we can choose between cut, color, or clarity. If we scroll down here, we can see that color is the diamond color, which is a quality rating from best to worst. So let's have a look at that. So to begin, we're going to say ggplot, and then we're going to say data equals data. And last time we were typing mapping equals aesthetic, but we don't actually need to do that, and we can just simply write aesthetic, and then we can go ahead and write x equals color, and then we can just add geom bar. So you can see this, get this nice little graph showing the frequency of each color quality of the diamonds. But we can also add a bit of flair to this by adding in fill equals the color. So that looks nice, and we can also make the labels a bit nicer by saying labs x equals diamond color quality, and we can just say that y equals the frequency. Cool. Now the next thing that we're going to be looking at is what I call general bar plots. So this is just bar plots that don't look at the count or the frequency. So to do this, we start off in the same way from last time. So we say data equals data, and then the aesthetic, we say x equals the color. But now, in this case, we need to add a y aesthetic. So it might be interesting to look at the price of the diamond for these different color qualities. And say fill equals the color. And then we go geom bar. And now we need to specify what the stat is. So we say stat equals summary. And then we say the function for the statistic is the mean. So now we get to see the mean price for each color quality of the diamonds. So this is a really nice graph. We can also change which functions we use. So we could use the minimum function, we can use the maximum function, or we could use the median function. Or you can specify your own function. So you can notice here that the price is in thousands of dollars. So we could simplify this by dividing the price by 1,000. So let's create a function now called mean div 1,000, which gets the mean and divides it by 1,000. So this is a function that will take in a numeric, and it will return the mean of x divided by 1,000. And then we can just go ahead and specify that here. Get rid of those brackets. So there you go. So now we've got the price there, and now we can update those labels. So we can use a similar label as before for the x-axis, but now for the y, it's not the frequency. So we want to say it's the price. We can say in thousands of dollars. Cool. So now I'll introduce you to ggcolumn. So I have some notes on this, which I'll just quickly paste in. Basically, ggcolumn is a special case of gbar. It requires both an X and Y aesthetic, whereas in gbar, as we saw before, we can just specify it with only an X aesthetic. And it's only really good if we have one observation for each categorical variable. As you can see, gbar before is very versatile. So I'll quickly show an example where ggcolumn is good. So say we have a category which has 3 different levels. So we see A, B, and C. And let's just assign just some random numbers for a response. 2, 4, and 6. So we'll load those both in. And we'll create a data frame called data test. And this will be a data.frame. And then self category and the response. So now we can just similar to before, so we just say ggplot data equals data test. And on this stack, we can say X equals the category. I'm going to say Y equals the response. And then we just simply add ggcolumn. So we don't have to specify anything here in ggcolumn, so it's a bit simpler than having to do gbar. So I'll quickly show you how this would work if we did gbar. So we do gbar, and then we just say stat equals identity. So there you go. So you can see that ggcolumn is just a special case of gbar, and you only going to use it some of the time. And the main thing you want to know is gbar. Now, the next thing we're going to look at is tweaking your bar plot how you like. So the first thing that we're going to look at is reordering. So this is when you reorder the columns such that they're in ascending order. So from left to right, they're always getting bigger. And this can just make your graph look a lot nicer. So let's quickly look at the data before, and we'll have it not in ascending order. So X is equal to the color, Y is equal to the price, fill is equal to the color, and then we add our gbar, the stat equal to summary, and the function equal to the mean. We'll actually choose the median just to show off more how this reordering works. So you can see here it looks nice, but it definitely could look a bit nicer. So what we can do here is we can say reorder on the X, and so we're going to reorder color, and we're going to reorder it by the price. And the default is the mean. So what we need to do here is going to say function equals median. So there we go. Now we get a nice graph to look at. And we could of course do the same thing if we chose mean. Now if you do this, you need to be careful because your X label now looks bad. So you need to go ahead and rename that to diamond color quality. So another thing that you can do to add some more flair to this graph and add a bit more meaning is you can change the fill from being the same one as the x-axis to be another categorical variable. So now we can go change the fill to equal. cut. So this adds a bit more meaning to the graph now. So now we can see within each diamond quality how each cut is performing in terms of the price. And we can change these two axes around by saying X to be the price and Y to be the color. And now, of course, we need to change the labels around. So there you go. So that just puts it on its side, and that can be sometimes a better representation of the data. Now, final thing that you can do is in geom_bar here, you can say position equals position dodge. So what this does, instead of stacking the bars within each diamond color, it now puts them apart so they're more easy to compare. So this can be a really useful thing to do. And there's a second option for this called position dodge 2. And what this does is it separates the bars so that they aren't touching each other. So the final thing that we're going to do now is we're going to look at adding error bars. So to do this, I'm going to be looking at the iris dataset, just because it's a smaller dataset and a bit easier to manage. Now the first thing I'm going to do is say mean data is equal to aggregate petal by species. So what this is doing is, I'll explain in a second, is it's grouping the data set by species and it's getting the mean of the petal width and it's creating a table out of that. So now if we go ahead and look at mean data, we can see we've got species. So for each species, we have the mean petal width. And now we want to go ahead and do a similar thing, this time for the standard error. Now R actually doesn't have a built-in standard error function, so I'm going to quickly make one now. To do this, we simply type function x, and then we just say return the standard deviation of x divided by the square root of the length of x. We can run that, and now we get the standard error of each petal width for each species. Now we want to combine these two data frames together. So what we can do is type error data. We can make that a column bind of mean data with standard data, and just looking at the petal.width column, which gives us the standard error. If we look at column names now for error data, we'll see that this is species, petal width, and petal width. So not very informative. So we need to change that now to still be species for the first one, but to be mean and the standard error. So now we can look at our data. So now we have the mean and standard error for each species, and now we can quite easily make our plot with error bars. So the first thing we need to do is say data equals error data, and then for the aesthetics, we say x equals the species, we say y equals mean, we say color equals species, then we simply add gmcol, and then we add gm error bar. And then on the aesthetics, we need to say what the minimum and maximum value will be for each error bar. So in this case, it's just going to be mean minus the standard error, and then y max is going to be the mean plus the standard error, where standard error refers to the name of that column. This is good, but I've said color here instead of fill, so let me quickly change that. So there we go. It's a fairly nice graph, but the error bars do look a bit big at the moment, so we'll change the width of them to be about 0.2 the width of each bar. And we can also change the color for them. So we could change that to blue, for example. Now you can also change as well a number in front of these standard errors if you want to create different sized confidence intervals. For example, you might choose the number 1.96. Now, there's a second way to do this, which I'll outline now. And this is using dplyr. So that can do what we did above here, all in one line, bar the standard error function, which is very handy. Except for the plot, of course, so it's just the data preparation step. So to do this, make sure you have dplyr installed. You can search it up here and install it. And then you need to load library dplyr. I'll just say data is iris again. And then all we need to do is say data is equal to data. And then we use this piping command, which performs a function on data. And then we group by the species, mutate with and then we simply mutate, which adds additional columns to the data set depending on what we've grouped by. So now we get the mean. We're going to add a new column called mean, which takes the mean of petal width for each species in the iris data. And then we create a new column called standard error, which takes the standard error of the petal width for each species in the iris data. And now we can see if we look at our data, we've got two additional columns called mean and standard error. So now fairly similar to before, going to use a similar code, but on the Y, we'll just say petal width. Instead of geom column, we'll be using geom bar with a stat equal to summary and the function equal to mean. And we of course need to change that data set to data. And we can see that we got the same plot as we did last time. So we can see that this dplyr method really speeds up the whole process, but you can do it in the base package. And one final thing that I'll talk about is subsetting. And I'm going to load back up that graph that we had before. So a powerful thing that you can do is you can actually subset this data set according to some condition. So for example, they wanted to look at this data, but when the caret was greater than 0.4, for example. So we can easily do that. We can just say subset data caret is greater than equal to 0.4. So now we can see how these trends change as I change this variable. Say less than 0.2, so there's not barely any observations, less than 0.4, and so on. Or you could use a different variable like the depth. So it really just adds a lot of things that you can show. So I hope you've really enjoyed the video today and gotten something out of it. Let me know in the comment section any feedback you have or questions, and I'll try to get back to you. Leave a like if you enjoyed the video and subscribe for more videos in this series. There will be many more coming, and I will see you in the next one. Cheers.